The first weeks of 2026 were supposed to be different for Russia. But at 0447 hours on January 6th, something impossible started happening across multiple Russian positions simultaneously. Ukrainian forces had just launched their opening blitz of the new year, and the Russian front line was about to discover that winter 2026 would be nothing like what Moscow had planned. The S-400 radar operator at checkpoint Delta 7, near the Donetsk supply depot, was staring at his screen when 12 objects appeared at the edge of his coverage zone. They were moving at 380 kilometers per hour, altitude varying between 150 and 800 meters, and they shouldn't have been there. Russian intelligence had reported Ukrainian drone production was crippled. They were wrong. These weren't ordinary drones. Ukrainian engineers had spent the winter months developing what military analysts would later call the most cost-effective weapon system of the entire war. Modified long-range strike drones with auxiliary fuel tanks, fiber optic control cables, and AI-assisted targeting. Each unit cost less than $15,000 to produce. The ammunition depot they were approaching contained over 2,000 tons of artillery shells worth $127 million. The mathematics of modern warfare was about to shift dramatically in Ukraine's favor. At exactly 52 kilometers from target, the lead formation executed a maneuver that Russian air defense operators had never encountered before. 4 drones suddenly climbed to 1,500 meters, exposing themselves completely to radar tracking. The S-400 battery commander had 14 seconds to make a critical decision. His training was clear. High-altitude targets moving at cruise missile speeds were priority threats. He fired. 2 48N6DM interceptors roared from their launch tubes, accelerating to Mach 6 in 3 seconds. But the moment the missiles committed to their trajectory, the climbing drones deployed corner reflectors. Triangular pieces of aluminum that cost less than a morning coffee, yet created radar signatures identical to KH-101 cruise missiles worth $3 million each. The real attack was coming from an entirely different direction. While every Russian radar operator focused on the spectacular high-altitude threat, 8 drones had approached from the opposite vector at just 50 meters altitude. They were using the terrain, following river valleys and forest lines, maintaining altitude so low that ground-based radar couldn't detect them beyond the horizon. At 50 meters elevation, the radar horizon extends only 8 kilometers. The drones were inside the detection envelope before anyone realized the high-altitude group was a diversion. The Pantsir S-1 batteries protecting the depot had a fatal design weakness. Their phased array radars were fixed mount systems. They could electronically steer the detection beam 45 degrees left or right, but to cover the rear sector required physically rotating the entire 3,000-kilogram turret assembly. That mechanical traverse took 4.7 seconds. The Ukrainian planners had calculated every millisecond. The first warhead struck the depot's main ammunition storage facility at 0451 hours and 17 seconds. The shaped charge created a jet of molten copper moving at 2,800 meters per second, 9 times the speed of sound. It penetrated the reinforced concrete roof exactly where structural analysis had identified the weakest point, where steel reinforcement met concrete foundation. Inside the facility, the initial explosion triggered a cascade reaction. Artillery propellant charges ignited first, reaching temperatures of 1,200 degrees Celsius in under 2 seconds. The pressure wave propagated through the storage compartments, detonating 152-millimeter shells, then 122-millimeter rockets, then the thermite-based incendiary munitions stored in the eastern section. The mushroom cloud climbed to 1,400 meters altitude in 4 seconds. Russian emergency response teams would later estimate that 68% of the depot's total ammunition stockpile was destroyed in the first 90 seconds. The remaining 32% was damaged beyond use by the heat, shrapnel, and structural collapse. Three mechanized divisions preparing for offensive operations in the Donetsk sector had just lost their entire artillery ammunition reserve. But the ammunition depot strike was merely the opening move. 470 kilometers to the north, Ukrainian forces had been monitoring Russian logistics movements for 3 weeks. Intelligence identified a critical vulnerability in the enemy supply network. A single rail line carried 60% of all ammunition, fuel, and equipment to Russian forces operating in the Kursk direction. Severing that line would paralyze offensive operations across an 80-kilometer frontline sector. At 05:03 hours, 12 fiber-optic-controlled drones approached the rail junction near occupied 𝙄𝙣𝙩𝙤. Russian electronic warfare vehicles immediately activated, flooding every radio frequency from 100 MHz to 2 GHz with 10 kilowatts of jamming power. Enough electromagnetic interference to blind every commercial drone control system within 30 kilometers. The Ukrainian drones kept flying. Fiber optic cables don't use radio frequencies. They transmit data as pulses of light traveling through glass fibers at 200,000 kilometers per second. Jamming radio waves to stop a fiber optic signal is like trying to stop someone's flashlight by shouting at it. The physics simply don't interact. The $10 million Krasuka 4 electronic warfare vehicle might as well have been an expensive paperweight. Through their drone cameras, Ukrainian operators watched as a Russian ammunition train approached the kill zone. 37 wagons carrying artillery shells, rocket munitions, and fuel for armored vehicles. Intelligence estimated the cargo value at $127 million. But the true value wasn't monetary, it was operational. Those munitions were scheduled to support a Russian offensive planned for January 8th. 4 drones released thermite charges onto the railroad tracks 800 meters behind the moving train. Thermite burns at 2,500 degrees Celsius. Railroad steel melts at 1,370 degrees. Within 8 seconds, 4 sections of track had transformed into puddles of molten metal. The train couldn't stop in time, and it couldn't go forward. The remaining 8 drones struck in precise sequence. Wagon 3's fuel valve assembly ruptured, spraying pressurized diesel. Wagon 7's brake line severed, locking every trailing wagon's wheels simultaneously. Wagon 18's ammunition compartment took a direct hit, starting a chain of secondary explosions. Wagon 22 contained 12 tons of 𝙄𝙣𝙨 thermobaric rockets. The warhead impact pushed the internal temperature past 447 degrees Celsius, the auto-ignition point for the fuel-air mixture. The resulting detonation vaporized 5 wagons into plasma. The blast wave lifted wagons 25 through 47 completely off the rails, flipping them across the countryside like toys. $4,800 worth of modified drones had erased $127 million in Russian military assets and severed the only supply line feeding 3 divisions. The January 8th offensive would never happen. But Ukraine's opening blitz of 2026 wasn't finished. While Russian commanders scrambled to assess the damage to their frontline logistics, Ukrainian forces were preparing strikes that would reach far beyond the immediate combat zone. The strategic objective was clear: force Russia to redeploy air defense systems away from the battlefield to protect critical infrastructure deep inside Russian territory. Every S-400 battery protecting an oil refinery meant one less S-400 covering frontline troops. Every gap in battlefield air defense meant Ukrainian HIMARS systems could operate freely. At 03:47 hours on January 7th, Ukrainian long-range drones approached the Yaroslavl oil refinery, 630 kilometers inside Russian territory. This facility processed 11 million tons of petroleum annually, supplying 40% of Moscow's fuel requirements. It was defended by 4 S-400 batteries, 2 Pantsir S-1 systems, and a Krasuka 4 electronic warfare vehicle. The defenses were formidable, but Ukrainian planning had identified exploitable weaknesses. The S-400 system uses semi-active radar homing for its interceptor missiles. The missiles themselves don't carry independent radar systems. They require continuous radar illumination from the ground station to track targets. This creates a vulnerability. If the target drops below the radar horizon, the illumination beam is blocked by the curvature of the Earth, and the missile becomes blind. At exactly 52 kilometers from target, 27 kilometers from the nearest S-400 battery, the lead drone climbed sharply to 800 meters altitude. The S-400's fire control computer calculated intercept parameters and launched 2 missiles. The missiles would need 27 seconds to reach the target position. But the Ukrainian drone operators had calculated that at emergency power settings, their drones could reach the 2-kilometer radar dead zone in 19 seconds. That gave them an 8-second margin. The moment the missiles launched, the drones dove back to 200 meters altitude, vanishing below the radar horizon. The S-400 missiles, designed to intercept cruise missiles and aircraft at high altitude, sailed harmlessly through empty air 80 meters above where the drones had been. 3 drones found their targets. The Cascade consumed 140,000 tons of petroleum products. Within 90 seconds, the entire western section of the refinery was an inferno, reaching temperatures of 1,200 degrees Celsius. It would burn for 72 hours. Moscow's fuel supply had just been cut by 40%. The same night, 2 modified long-range drones reached Penza, 630 kilometers inside Russian territory. This shouldn't have been possible. Standard Ukrainian strike drones had a maximum range of 350 kilometers, but these weren't standard platforms. Ukrainian engineers had sacrificed 5 kilograms of explosive warhead capacity to install auxiliary fuel tanks, extending operational range to 980 kilometers with 30 minutes of reserve endurance. The target was a semiconductor fabrication facility producing military-grade processors for Russian air defense systems, communications equipment, and precision-guided munitions. Western sanctions had made these chips impossible to import. Destroying the facility would create supply chain disruptions that would cascade through Russia's entire military-industrial complex for months. At 20 kilometers from target, an Su-35 fighter detected the incoming drones and fired 2 R-77 missiles. These weren't ordinary interceptors. They used active radar homing with autonomous seekers. Once launched, they required no guidance from the firing aircraft. The Ukrainian drones had no electronic countermeasures, no chaff, no flares, no jamming systems. Their only defense was kinematic maneuvering. The flight control computer initiated barrel rolls while varying altitude between 150 and 800 meters, creating angular velocity that exceeded the missile's gimbal tracking limits. The first R-77's proximity fuse triggered at 80 meters, sending hundreds of tungsten fragments through the drone's fuselage. Control surfaces locked at random angles. Half the vertical stabilizer was gone, but the engine kept running. The damaged drone's flight computer calculated impact in 40 seconds. Current trajectory would miss the target building by 40 meters. The autopilot executed a maximum thrust pulse in the final 3 seconds, burning the last reserves of fuel to correct the trajectory. The drone crashed through the semiconductor facility's roof at 273 meters per second. In normal circumstances, 15 kilograms of explosive wouldn't devastate an industrial building. But semiconductor fabrication requires ultra-clean environments. The explosion overwhelmed air filtration systems designed for 0.3 micron particles with millions of concrete and metal fragments. The electron beam lithography system, worth $47 million and requiring 18 months to install and calibrate, was destroyed. Ion implantation equipment vaporized. 6 months of military processor inventory became silicon dust. Russian military chip production was paralyzed for a minimum of 6 months. Within 6 hours of the opening strikes, Russian military command initiated the largest air defense redeployment of the entire war. S-400 batteries were pulled back from frontline positions to protect oil refineries, ammunition depots, and industrial facilities deep inside Russian territory. Pantsir S-1 systems were redirected to cover critical infrastructure. Ukrainian military intelligence documented the movements through satellite imagery and electronic signals intercept. By January 10th, Russian air defense coverage along the Donetsk and Zaporizhzhia front lines had declined by an estimated 35%. That same day, Ukrainian HIMARS units conducted 18 precision strikes against Russian command posts, logistics hubs, and artillery concentrations. 16 of the 18 strikes achieved direct hits. Before the air defense redeployment, Russian S-400 systems would have intercepted at least 12 of those HIMARS rockets. The cost-effectiveness was staggering. Ukraine had spent approximately $412,000 in drone production and operational costs to inflict tens of millions of dollars in direct damage, force a strategic air defense redeployment, and create operational opportunities for conventional artillery systems. But the real victory wasn't measured in dollars or destroyed equipment. It was psychological. Russian military command faced an impossible dilemma. If they concentrated air defenses on the front line, Ukrainian long-range strikes would devastate critical infrastructure. If they protected rear-area facilities, frontline troops would be exposed to Ukrainian precision artillery. There was no solution that didn't involve accepting unacceptable losses somewhere in the defense network. By January 12th, Russian offensive operations in multiple sectors had been postponed or canceled due to ammunition shortages caused by the January 6th depot strikes. The planned offensive toward Slovyansk, which Russian command had been preparing for weeks, was indefinitely delayed after the ammunition train destruction severed the primary supply route. Ukrainian Commander-in-Chief 𝙄𝙣𝙨 𝙤𝙝 stated in an interview with LB.UA that Ukraine's offensive operations in early 2026 were designed to prevent active movements of Russian forces, forcing them to deploy significant manpower and resources defensively rather than offensively. The strategy was working. Military analysts noted that Russia's fundamental problem in early 2026 was the same issue that had plagued Soviet military planning for decades. Centralized logistics networks create single points of failure. Ukrainian forces had identified those critical nodes and developed cost-effective methods to destroy them faster than Russia could rebuild or reroute. The January 2026 operations demonstrated several technological and tactical innovations that would reshape modern warfare doctrine. Fiber-optic-controlled drones proved immune to electronic warfare systems that cost tens of millions of dollars. Corner reflector decoys, costing less than $10 to manufacture, successfully deceived radar systems designed to track supersonic cruise missiles. Most significantly, Ukrainian forces demonstrated that with proper planning and precision intelligence, small teams operating inexpensive weapons systems could achieve strategic effects previously requiring large-scale conventional military operations. The psychological impact on Russian forces was measurable. Intercepts of Russian military communications showed increasing concern about the vulnerability of rear-area logistics. Troops stationed at ammunition depots and fuel storage facilities reported heightened stress levels. Several units requested reassignment to frontline positions, where they felt paradoxically safer from Ukrainian strikes. By mid-January, Russian command had implemented new security protocols requiring constant movement of high-value targets, dispersal of ammunition stockpiles, and redundant supply routes. All of these measures reduced operational efficiency and increased logistics costs. Ukraine's January blitz had forced Russia into a defensive posture across multiple domains simultaneously. Despite the spectacular deep strikes, the frontline situation in January 2026 remained challenging for Ukraine. Russian forces continued grinding offensive operations in Donetsk Oblast, though at slower pace than Moscow had planned. Ukrainian military personnel acknowledged that the goal for 2026 was survival and gradual attrition of Russian combat power rather than dramatic territorial gains. But the early January operations demonstrated that Ukraine retained both the capability and willingness to conduct offensive operations when conditions allowed. The strikes forced Russian command to maintain defensive deployments across vast rear areas, tying down air defense systems, electronic warfare units, and security personnel that could otherwise support frontline operations. Western intelligence estimates indicated that by mid-January, Russian forces had been compelled to deploy approximately 15% of their total air defense inventory to protect rear area infrastructure rather than supporting combat operations. That redeployment created exploitable gaps in frontline air defense coverage. Ukrainian drone operators and HIMARS crews were exploiting those gaps daily. The cumulative effect of Ukraine's January 2026 operations was forcing Russia to fight a two-front war. One front was the traditional ground combat in Donetsk, Zaporizhia, and Kherson. The second front was an asymmetric battle, where Ukraine used precision strikes and cost-effective weapons to attack Russian logistics, infrastructure, and command facilities across a theater spanning over 1,000 kilometers. Russia had the resources to fight one of those wars effectively. Fighting both simultaneously was draining capabilities faster than Moscow could regenerate them. As January 2026 progressed, Ukrainian military command continued refining the tactics demonstrated in the opening weeks. Drone production accelerated. Fiber optic control systems were standardized across multiple platforms. Intelligence gathering focused on identifying additional critical nodes in Russian logistics networks. The question facing Russian military planners was stark. How do you defend everything when the enemy can strike anywhere, and the cost of defense exceeds the cost of attack by orders of magnitude? Traditional military doctrine offered no satisfactory answer. Ukrainian forces had demonstrated that modern warfare increasingly favored precision, intelligence, and innovation over mass and firepower. A $15,000 drone guided by a skilled operator with accurate intelligence could achieve effects that previously required million-dollar cruise missiles or battalion-scale conventional attacks. The Russian front line hadn't collapsed in the dramatic sense that the title might suggest. But across multiple sectors, Russian operational plans were disintegrating. Offensives were canceled. Supply lines were severed. Air defense networks were redeployed. Industrial facilities were burning. The cumulative effect was strategic disruption on a scale that Russia hadn't experienced since the early months of the war. Ukraine's first blitz of 2026 hadn't ended the war, but it had demonstrated that despite nearly 4 years of brutal combat, despite ammunition shortages and manpower challenges, Ukrainian forces retained the capability to seize initiative, impose costs on the enemy, and shape the battlefield through innovation and precision. The war would continue, but January 2026 had shown that Russia's path to victory, if it ever existed, was growing narrower with each passing week. Ukraine's strategy of forcing Russia to defend everywhere while concentrating Ukrainian strikes on critical vulnerabilities was working exactly as planned. The opening blitz was complete, but the campaign was just beginning.